All right, the end is near. We are almost done. We are in section 13.5. With this section and another one to go, we are soon to be out of here. What we're going to talk about today is the law of sines and applying the law of sines, and we're going to see how that kind of how that works for us. So the law of sines is right down here. Given any triangle, that does not have to be a right triangle. This is the first time we're dealing with something that does not have to be a right triangle. Given any triangle, this holds true. So let's see how we'll use that information. The triangle with A is 28, B is 102. So if I draw this, and I don't really care that I draw it real well, but if this is 28, that's big A. Little a is right across from it. And if big B was 102, little b is right across from it. Now, I don't think my picture is very proportional, but that's okay. And we said little a was 8. So we're going to make this 8 down here. That makes this big C and little c over here. So when it says solve the triangle, you have to find all the missing parts. Now the one missing part to find, big C, is pretty easy. If I add 102 plus 28, I get 130, so big C was 50. All right, that wasn't too bad. Finding the rest of them, I can use a number of things, but the law of sines is the one that pops out. That's what we're going to use first here. So little b over the sine of 102 equals 8 over the sine of 28. Now if I just multiply both sides by the sine of 102, multiply both sides by the sine of 102, I end up getting 16.7 approximately. And then little c, I can find little c by using the law of sines again, because I know that c was 50, little b was 16.7. So on this one, I'm going to multiply both sides by the sine of 50 to cancel these sines of 50s out. And I'm going to get c is approximately 13.1. And now at this point, you ask yourself, does this all make sense? And so if I had a triangle with a side length 8 and 16 and 13, well, that makes sense. Yeah, well, 8 plus 13 is 21, so the two small sides add up to something bigger than the other side. So that works. All right, the one why I mentioned that concept is because you have some possible errors coming up here. Okay, when we look at these things, there's times when you're going to have no triangles. There's times when you're going to have multiple triangles. If you have a system like this, where you have your leg here, and then it's an obtuse angle, if A is too small, if A is smaller than B, then it's not going to be able to form a triangle. You know, remember, the two smallest sides have to add up to something bigger than the third side to form a triangle. If A is bigger than B, then you're going to be able, it'll reach down there and I'll get one triangle. When A is acute, when that angle is smaller, still we're going to note that H is equal to B times the sine of A. B times the sine of A. When A is still too small and it's acute, it can't reach, and you're going to have no triangles again. And when it's exactly the right number, you have one triangle. And we'll go over these in more detail in a minute. In this situation, this is the big one right here. This is the one that throws us off. So I'm going to hold that off. When A is larger than B, you have one triangle again. Okay. Here's the scenario. When you have a side and you have an angle and you have this third side coming up, okay, you have a possibility. If A was swung out to here, if this was A, that is a possible triangle that we could have. But if A was swung into here, that same length, that was A, you see this is why we don't have a side-side angle postulate. Because when you have that angle and these sides, this side and this side, or this side along with this side, you have a possibility of that thing swinging back and forth and creating two triangles for the same issue. So that's what we're going to be dealing with. Alright, let's see if we can apply that now. First of all, we have a triangle, ABC. Now I just sketch everything always. It says make a sketch, but that's a good idea to always do when you're dealing with these kind of things. A is 94, and little a is 18. And C is 13. Okay? Because A is obtuse, and A is longer than C, you're in that scenario where you have one triangle. A is longer than C, so you have one triangle. Remember, this is little a and this is little c over here. Alright, so we're going to use the law of sines. We have the sine of C, which we don't know, over 13, and then we're going to do the sine of 94 over 18. So we're going to multiply both sides by 13 there. And when I multiply by 13, I get the sine of C is 0.72 or about somewhere in there. And then I inverse sine like we learned in the last section, because sine of C equals 0.72, inverse sine, and I get 46.1 degrees. And we know that B, now that I know that C is 46.1, I know that B has to be 180 degrees minus 94 minus 46.1, and B ends up 39.9. So I have a lot of the parts now. I have 39.9, and I have 46.1. And I just have to find that little b. So if I'm finding little b, I can do b over the sine of 39.9, and on the other side of that, maybe I'm just going to go back with the trusted numbers. I'm going to do 18 over the sine of 94. Now you'll notice, sometimes we put sine on top, sometimes we put sine on bottom. Generally, when you put sine on bottom, it's because you don't know the side length. And when you put sine on top, it's because you don't know the angle. That way, all you have to do is multiply both sides. Like in this situation, I just multiply the right side by the sine of 39.9, jam all that in my calculator, and I get that b is 11.6. Alright. Now let's take a look at example 3. Example 3 is going to be a little bit different. In example 3 here, I'll change off this ugly orange color. I don't know how I got on that. When I take a look at example 3, we know some things. We know that big A is 77. We know that little a is 6.1, and we know that B is 9. Okay. So if we drew a horizontal line straight down, okay, if we drew on this horizontal line right here, what we're going to try to do is we're going to figure out what's the minimum length A would have to be to make this work. So this is the length of this. Now if I look at that thing as a right triangle, what I would see is that if I went with sine and I called this the opposite right here, and I said the sine of 77 equals the opposite over the hypotenuse 9. So we know, that's 9 units long, or, AC is 9 units long. And if we draw a segment that's 6.1 units long, the A over here, question is, would that work for X? Is that big enough for X? And we can see that A needs to be at least, and if I multiply both sides by 9 here, 9 times the sine of 77. 9 times the sine of 77 would be the minimal that it could be if it was just a right angle, which is 8.8. Well, simply 6.1 isn't quite 8.8. That makes this not possible. And you're going to have to play with those a little bit and see how you get. Not possible. All right. I'm going to let you guys work through these, and you're just filling out the triangles A, B, and C. And hopefully you get these 4 solutions. Hopefully you found that big A equals 49. Little a equals 17.8. And little c equals 5.7. On number 2 there, I hope you got big B was 33.6. And big C was 90.4. And little c was 28.9. And when you worked on number 3, and this is if you paused it and you put some time into it, and I hope you did that, no solutions. I hope you don't come back tomorrow and ask this in class if you didn't work on it. I hope you put some time into it. Alright, so example 4, here's the tricky one. Here's one we got to watch. We have triangle 1 and triangle 2. They just give us this and they say sketch this. So if you make your own sketch, I want to make my own sketch outside of theirs here real quick. A, B, C. A is 30 degrees. Little a was 10. And little b was 15. Okay. And what you need to know here is, remember when we had that H, when we talked about just dropping that line straight down here? We talked about dropping that line straight down there to try to figure out how long when A is swinging. And I guess I like their pictures a little bit better, but how long when A is swinging, that line that drops straight down there would be. So that line that drops straight down would be the sine of 30 equals the opposite, which is x, that would be that line, over the hypotenuse of it, which would be 15. And so we would have that 15 times the sine of 30. Now the sine of 30 is 1/2, and so half of 15 is 7.5. Now 10, that A number, is bigger than 7.5, so it works, but it's less than 15, so it creates 2 different triangles. So if you see, it's that swinging gate thing. It's that triangle that I don't know that bottom leg, how long it is, so it could be here or it could be here, forming 2 separate triangles. I know this length, and I know this angle. So that's why, again, SSA doesn't always work. That's why we didn't have it. Or ASS, which is a bad word, so we don't want to say that. So if we use the law of sines, the sine of B, to do each of these, the sine of B, which I don't know, over 15 equals the sine of 30 over 10. Alright, so if I multiply both sides by 15, the sine of 30, I end up with 0.75. The sine of 30 was 1/2, and so 1/2 divided by 10 would be like 1/2 times 1/10 is 1/20th, and 15 over 20 ends up giving me that 0.75 thing. There are 2 angles B between 0 and 180 for which the sine of B equals 0.75. So there's when we do that inverse sine thing. One is an acute angle and one is not an acute angle. Remember when we talked about the circle, okay, this is the sine up here, it's on the y-axis. At 0.75, we have this angle and we have this angle. So we have 2 separate angles that would equal that 0.75. So when I do the inverse sine of 0.75, I get 48.6. That's what your calculator is going to tell you. But the obtuse angle is going to be 180 minus 48.6. That's going to give you that reference angle, which is going to be 131.4. Those are my two possible angles, 131.4 or 48.6. Okay, so we found B. All right, so when we're looking at the triangle 1 has a B, we're going to say triangle 1 has a B of 48.6, and we'll say triangle 2 has a B of 131.4. All right. Now, when I go to find C, that's going to leave me two different types of answers. One of them is going to be 180 minus 30. They're both going to be 180 minus 30. One's going to be minus 48, or one's going to be minus 48.6. The other one's going to be minus 131.4. So that's going to be my big C. Big C is either 101.4 on one of the triangles or 18.6 on the other triangle. So you see how big C is going to change, and obviously when big C changes, little c changes. You know, if you look up here, little c is either small or it's really big. So we have a choice there. Okay, so C is to the sine of 101.4 as 10 is to the sine of 30. And C is to the sine of 18.6 as 10 is to the sine of 30 also. Okay, one of them I'm going to multiply by the sine of 101.4 and end up with a 19.6 for my little c. The other one, when I multiply by the sine of 18.6, I end up with 6.4. Good stuff. A lot of work. A lot of work. Alright, this is going to be a little break from that stuff, although it's all really related. We have a new formula for finding the area of a triangle. And this formula for finding the area of the triangle, there's three of them actually. One of them is 1/2 BC sine of A, and the others are all related to it. 1/2 AC sine of, which one do I not have in there yet? B. 1/2, I have BC, I have AC, I don't have AB, sine of C. Those are the three different formulas I can use to find area. So if I take those formulas and I apply them to find the area of this triangle I have here, a piece of land. This is the only real-world example we've seen so far. So I have C, so I'm going to use my A and my B and the sine of C. So I have 1/2, 1.4 times 2.3 times the sine of 78.1, and that will give me my answer, which is it's a pretty cool way to find the area of a triangle, 1.6. So your area is 1.6 square miles. You think you have to find the area of a triangular piece of property? Yeah, all the time. This is a great way to do it. All right, take a look at 4 and 5 here. Hopefully you worked on those a little bit. Pause right now. Work on them. Number 5, I hope you got 6.3 square miles. And number 4, there were two triangles. Okay, so I hope you realize there were two triangles right away. And on the first one, we had big B, big C, and little c we had to find. Big B was 46.9. Big C was 98.1. And little c was 19. On the other one, big B, big C, little c, big B was 133.1, 11.9, and 4 was the other one. All right, so that is 13.5, one lesson to go. Yeah.